All right, welcome back. All right, it's the last one. So let's talk about some possibilities that can happen on a graph, and so because so far we've been dealing with nice continuous graphs and taking a look at what those areas will look like. Well, one of the next questions that came up, well, what happens on a discontinuous function? So here we have the graph for the function absolute value of x over x, and we've seen this graph before. How do I, deal with this discontinuity? The good news is that, dealing with a hole or a jump, okay, discontinuity, there's no real difference in figuring out the area, okay? You just find the area underneath the curve. You don't have to worry about the hole. The only time we have to worry about it is when we have a vertical asymptote. So when you have vertical asymptotes or an infinite discontinuity, then we have some problems. So you can say that jumps and holes, not that type of hole, holes are okay. Okay, vertical asymptotes are a problem. And it's a problem that in AB calculus we don't have to worry about. The people over in BC calculus do. Okay? So in your second semester of calculus, you'll get it. So in finding this, it's just like finding the area. Okay? I know my height is 1. I'm going from, this is 0, there's 1, there's 2. So that means 2 times 1. This whole area is 2. This whole area is 1. But because that area is beneath the curve, the integral value is -1. So this is equal to 2 plus a -1, which is equal to 1. And that's the integral value. All right. So let's take a look at the next one. Next one is more of an exploration. And we have to look at this type of discontinuity. So we looked at a jump discontinuity. Now we're going to look at a hole discontinuity. How do I know what's a hole? Well, when I factor this out to x plus 2, x minus 2, all over x minus 2, these cancel. Because they cancel, I have a hole at positive 2. Okay? So I have a hole, not that type of hole again, a hole at x equals negative or positive 2. That's the type of discontinuity. So now we have to worry about, okay, so what does my graph look like? Well, if you don't remember, your graph is going to look exactly like what was left over, the x plus 2. So here's 2. Except when I get here at 2, there's a hole. Okay, so I'm going from 0 to 3. That means this height up here, this point, is 3, 5. And now I take a look and I see it's a trapezoid. So again, this is, that's base of 5, that base is 2. My length is, my height is 3. So it's 5 plus 2 divided by 2 times 3. 5 plus 2 is 7 times 3 is 21, is then equal to 21 over 2, which is equal to 10.5, which is what I wanted to show. Great. Now it says use areas to show that int x is equal to 10. Well, what does the int x mean? Okay, well that's my graph. Again, you can't remember what the graph looks like. It's the graph. It's a step function where over here to 1, it's 2, 3, 4, oops, 1 more, that's 5. So then you go and find the area underneath the curve from 0 to 5, and what you should see is that you have 4 rectangles and find the area of each one. I want you to remember again the step function. This goes up by steps of 1, 2, 3. And you find the area. Area of this one is 1 times 1, 2 times 1, 3 times 1, 4 times 1. And add them all up, and you get that to be 10. Okay. So discontinuities, as long as they're a hole or a jump, I'm okay. It's just finding the area that's underneath there. Vertical asymptotes, not okay. This one here says do number 24 from the definite integral supplement. So again, this is the sheet that you got hopefully this morning. And so I'm looking at number 24. And it says use numerical NINT. This piece right here means calculator. Calculator. Okay, to find the positive value. Okay, what does this mean in terms of area? Confirm it by graphing. So let's go ahead and take a look at our calculator. So we're going to get our calculators out. Okay. And let's go get that. And I already have in there the y1 cosine of square root of x. But what I want to do is I'm going to go back to my home screen, clear out what's there, and I want to do the integral. So where's the integral? Well, much like we had a way of doing it, and we want to go from 0 to 4, we had, you're going to do math 9. So hit math, number 9, and there's your integral set up. And you're going to do from 0 to 4. And of course you want y1, so you can do vars, y vars, function, y1. And you're going to take the antiderivative with respect to x. Okay, and you go ahead and hit graph. Not graph, excuse me, enter. And there it is, 0.8048. Okay, so you could have gotten an answer of 0 to 4 cosine square root of x equal to 0.804. Okay, or you can have it as 0.805, depending if you round or you cut off, your choice. All right, interpret the result in terms of areas. Well, for me to be able to pull that off, I need to go back to my calculator. And then you go back and take a look at, okay, what does this mean? So when I go and I take a look at the graph of this, I hit graph. I already zoomed into it, and I take a look. I want to go from 0 to 4. Well, 0 to 4, here it is. Look, it kind of looks like there's more positive area than the negative area. So it's going to be a positive value. Again, not negative area. There's more area above the axis than there's area below the axis. So I'm going to have a positive integral. So if you want to, again, do this on the calculator and look at the shading in, hit second calc or second trace to get to the calculate part, and look at number 7 there that has the integral. And it's going to want your lower limit and upper limit. And here you can type in what your lower limit is. You want x to be 0, so you type in 0, and you hit enter. What's your upper limit? Again, you're going to type in 4, and you hit enter. And there it goes, shading in. And you can actually see the shaded in. The shaded area above the x-axis is greater than the shaded area below the x-axis. And that's what you would say here, interpret the result in terms of area. You say, well, the area above the x-axis is greater than area below the x-axis by how much? 0.804 units. Pretty cool, huh? You gotta remember, that's the context of it. All right? Cool. Let's see what's next. It So here they give you a whole list of problems to go ahead and try and find out what it is. You know, what this all this, you know, integral stuff. I'm going to take you through a couple of them. The way I always do with these types where they have an area is I go and find the area of all the little pieces. And so I have this area right here is going to be 1/2. This area right here is 2. The area right here is also 2. And the area here, they tell me, is A. So when I want to go to the, you know, find the integral value from -4 to -3, I see that my area above the x-axis is 1/2, and that's all it's going to be. 1/2. Boom. Done. Next one says go from -4 to -2. There's that right there. Well, when I go ahead and I do that, from -4 to -2, I have a 1/2 above the x-axis. I have a 1/2 below the x-axis. So I have 1/2 minus a 1/2, which is going to be equal to 0. And so what I want you to do is take a moment or two. I'm going to pause the video. You're going to find out the rest of these on your own and see if our answers match. Okay? There we go. Boom! There's the answer. Wow, that was, you know, surprising answers, right? The ones I do want to point out here is again on H. I'm assuming a symmetry on it. Okay, so that's why it's a -1/2 A. Again, remember the area is A, but the integral value is -1/2 A. Okay. I guess that's it. Your homework is next. Okay. It looks like a lot. It's a little bit. Okay. You're gonna have you're gonna have some time to get this done. Okay, but the next one's coming. The next video is coming right behind this one, so keep up with it. If you have any questions, make sure you ask me tomorrow. See you guys later. Bye.